So, good morning, everyone. We're going to start again now. You've got the dubious honour of having me for the rest of the day. Okay, don't look quite so sad about that. It won't be as bad as you think. To start with, because I'm not going to talk all day. So the idea is that this afternoon, you are going to engage in an exercise, which I'm going to take you through a little bit later on. So it's about you doing the work. And I'm just going to float around and sort of give you a few ideas about what you're doing. To start with, though, I'm just going to give you a couple of talks to give you some background information about some of the issues we're going to be addressing as part of the exercise this afternoon. And I've been asked to give a sort of very broad overview about some of the important land use change issues in the past, present, and in the future, with just a few examples. Now, I'm going to do this by, first of all, looking at very sort of broad trends at the global scale. And I'm gradually going to come down the scale levels through continental Europe mostly, and then down to particular case studies. And all the way through, what I'm going to try and do is to introduce you to the different notions of different drivers of change, so the underlying causes of change, but also to think about the processes of land use change themselves that are affected by those drivers. So, just for all of the tree huggers in the room, I thought I'd start with forest areas, okay? There we are. I thought I'd get your attention, Sebastian, with that one. Okay, so this is some general data from the Millennium Ecosystem Assessment, which looks at changes in forest area globally from pre-conversion situations. So it's not sort of time limited, it's just from when forest was converted in the past. And what you can see, there are different colors on this particular map. So we have the areas which are in the pale green gives the current forest cover areas. We have areas in red which show the net loss of forest, so deforestation. And we have areas in the dark green which show areas of reforestation, so gains in the forested areas. And what's quite interesting about this picture, and I'm going to show you this sort of trade-off as we go through these various things. People think about trees, they think about deforestation. And of course you can see the classic Amazonian and equatorial deforestation geography that everyone's familiar with. But if you look at places like Europe and North America, you can see that there's been fairly important reforestation over the last decades. So a number of different reasons for this. So most of these slides, what you'll see at the bottom is that I've listed a few drivers here just to give you some general ideas about what are the causes, the underlying causes of this. So things like population growth, obviously the economics of timber production, the use of forest for local fuel, and competition with other land uses, such as agriculture and urban, are some of the sort of general level drivers that are important in understanding these processes. So let's just take that on. So I mentioned to you that there's a different geography of deforestation and reforestation. So this is some data from the World Bank, which just divides the world according to country groups based on income levels. So what you've got are the low, lower middle, upper middle, high income classes. And what you can see here is the median rate of forest reduction or deforestation, which, as you can see from this table here, is highest in the low income countries. This gives a halving time of forest areas of 90 years. If you look down at the high income countries, then you have a negative value, so actually you're getting reforestation, a negative deforestation. So that's the situation. So clearly, there are different processes of forest land use change going on in different parts of the world. And we can look at, if you zoom into the European context, for example, we can see that certainly since the 1960s, there's been a fairly substantial increase in forested areas. So if you just look at the y-axis, we're probably, at a guess, around about 12 to 14% increase in area over the last 50 to 60 years. So it's quite an important trend. So what are the differences here between the poorer countries of the world and the more developed countries of the world? Well, there's a number of reasons for this, which are sort of basically listed on the slide here. So, for example, in developed countries, there's no longer the use of wood as a major fuel source. So we have wood substitutes, for example. It's the end, as we'll see a little bit later, the end of the era of agricultural expansion. So, in fact, agricultural areas in Europe are contracting, so we can have more forested area. Developed countries tend to have different and diversified trade patterns, manufactured goods rather than primary sector goods. And finally, what's increasingly important in the European context is that forests are seen for their amenity value as public services, so they tend increasingly to be protected because of that reason. So a number of different processes that are unfolding in different parts of the world, which we need to understand those differences. So I mentioned competition with agriculture, and this graphic demonstrates this quite nicely. So what we have here are the bars which are in green show the change in the area of forested areas. The areas that are in purple show the change in agricultural areas, both for the globe as a whole, but also broken down into those major world regions. And what you can see is that, again, the similar trends I was showing you earlier. If you look at, say, what should we pick out here? If you look at Africa or Latin America, then you get decreases in forested area. That means the bars go to the left-hand side from the 0 line in this particular case. But if you look at other countries, such as Europe, then you have increases. So if you look at this particular bar, you have increases in forested area. That's the European Union. China has increases in both forested area, but also increases in agricultural area, which is quite interesting. So you can see some of that trade-off that's going on here. And again, in the European context, we have decreasing agricultural areas, but increasing forested areas, which is different in different parts of the world. So clearly there is a tension and a competition between these different land uses. So let's move on to cultivated areas. I think as Alma was introducing earlier on, clearly the area of cultivation is extremely important across the globe. It's one of the sort of biggest influences that people and society have had on the Earth system through land use change. So about, in the year 2000, about 24% of the terrestrial surface was under cultivation. And the brown areas on this graph just demonstrate where those areas are. So it's extremely important spatial extent. Again, you can see the sort of mid-latitude areas, cultivation is extremely important. What's interesting, though, is we're observing certain trends in the rural areas that relate to agriculture. And what this shows is two interesting curves. The lower curve is the GDP, which is the share of the global GDP attributed to the rural areas. And what you can see from the 1800s, or from about 1800, rural areas accounted for, and this is largely agriculture, but also forestry, largely accounted for about 80% of the global GDP. Okay? And that has fallen rapidly, where we're down to a situation, well, the curve stops in the mid-1970s, but we're down to about 3, 4, 5%. So it's an enormous change in the balance of the economics of the use of land. But at the same time, what you can also see on the top curve, which is quite interesting, this is the rural population and how that share has changed through time as well. So back in 1800, almost 100% of the world's population were located in rural areas, so cities were actually quite small. But what you now see, for the first time relatively recently, the share of the rural population has now fallen to below 50%. So what that means, of course, is that we are increasingly an urbanized society, and urban land use is one of the key issues that we need to think about. So continuing my grand tour of the major global themes, if we think in terms of urbanization, what we've seen, this is some data from the National Geographic, if you look back in the 1950s, there were very few what are termed megacities, so cities with more than 10 million people, 10 million inhabitants. But what you see in the year 2000 is the number of these cities has increased substantially all over the world, so it's a globalized phenomenon, and there are projections into the future about how that will increase. So urbanization is extremely important. And the consequences of all of these types of global changes are, again, the types of things that Alma was introducing earlier, which is that the natural biomes, the natural world that we consider pre-intervention from people, has changed dramatically over the world. And these different types of biomes, you can see, are affected in very many different ways because of land use change. Okay, so let's just drill down a little bit. So I started off at the global level. I'm just going to bring it down to the European continent now, mainly because the exercise you'll do later is focused on Europe. So we'll just look at some of the processes here. So I talked a little bit about the decline in areas of agriculture in Europe and North America. This is often surprising to people. They don't necessarily realize. People assume that agriculture is constantly expanding everywhere. In actual fact, it's not. In North America and Europe and other parts of the world, you have these fairly substantial decreases. And as you can see, it's almost a linear trend And over the period from 1960 up to more or less the year 2000, again, you have something in the order of about 12 to 15% decline in the area of agriculture. So can we understand, this is from observational data, can we understand what's going on and why this is the case? Well, one of the crucial things is, let's say broadly termed, the Green Revolution, is due to this. So this shows a graphic for over the same period of time, from 1960 up to about the year 2000, the change in the yields of wheat, one particular crop. Actually, most crops follow similar trends to this. And what you can see, so wheat yields on average, let's look at the top curve first of all. This is the former EU 15, so the Western European countries, and this is the Central and Eastern European countries who are now part of the EU 27. So the data is a little bit old, but it's just to show a point. If you look at this curve, again, you've got a fairly linear response of increasing crop yields. If you look at the axes here, you're going from 2 tons per hectare up to nearly 6 tons per hectare. So we've increased crop yields by almost 3-fold over that period of time. That's an enormous increase in production. So that's the case for the EU 15. The other curve is quite interesting as well. So you may have noticed that it follows a different trajectory. It's very, very similar in the east of Europe up until a certain point of time. So I guess you can probably understand what's going on there. Anyone want to hazard a guess? Very good, thank you. And actually what happened, you can see pretty much it's at the end of the 80s and the early 90s that you have this decline. And this was really all to do with changes in the farming structure, reallocation of land, lack of financial resources to invest in things like fertilizer and other agrochemicals. So the yields actually decreased. So that was, as an example of a driver of geopolitical change having an influence on crop yields, which ultimately will have an influence on land use. Now, why is this significant? I'm showing you earlier the decreases in agricultural areas. Well, if you think about this quite simply, if you increase the production from a unit of land by 3 times, you need, on average, if everything else stays the same, 1/3 of the amount of land to match the same demand for food. Okay? Well, it's not quite as dramatic as that, but actually that's pretty much what's going on. Because we can produce more food per unit area, we actually need less area to produce the same amount of food. Right, so let's look at a few other drivers and processes of change. This is an interesting example and a very typical one. So this is the area of maize cultivation. Again, this is in Western Europe. This is the data I just got to hand. And it's quite an interesting curve you can see there. So going back from 2000s back to the sort of 1970s, you've got a fairly sort of steady, gradual change with sort of year-to-year variability. Increasing, but what you'll see is around about the mid-60s, this dramatic increase in maize areas. The reason for that is just very simply that this was the introduction of new varieties of maize which could be produced under cooler climates. So at that point, you had a northward expansion of maize production across the European continent. Right? So the driver there is biotechnology and development leading to increases in the geographic distribution of this particular crop. So land use change driven by technology. Here's another example. So drilling down again, I don't know why my map here has become decapitated. Anyway, I'm from Edinburgh, there we are. But Scotland's disappeared, but we won't worry about that. So this shows data, again, this is observational data for the production of oilseed rape in Great Britain. It was probably before your time, but I certainly remember, and some of the others in this room will remember, Joe doesn't remember, yeah, the time when suddenly these yellow flowers appeared in the landscape when people started producing oilseed rape. And that's because the change was very, very rapid. So in the sort of 1970s, you just had a scattering. This is the distribution of oilseed rape in the east of England. Scotland's not there because there was none in Scotland at that time. 85, a sort of fairly massive expansion and further expansion through the 90s. And it follows this actually, as I'll come back to a little bit later on to explain to you, this logistic sigmoidal curve. So what happened? It's all to do with international trade. Due to changes in the US soybean production, the European Union introduced a subsidy for the production of oilseed rape. Okay? Simple as that. You introduce a subsidy, it's another driver, it's a policy change, and you get a big change in land use at this particular crop as a consequence. It's not quite as straightforward as that, and I'll explain a little bit later on. Keep in mind here that what you've got is actually not an immediate uptake of this new crop, even though it was probably profitable to do so. And I'll come back to explain some of the reasons for that a bit later on. I'll show those data later. Right, so here's another example. There's nobody here from Belgium, is there, except for Sebastian? Is that right? I'm going to show some data for Belgium. So this is, I'm just sort of drilling down. We're just thinking again about processes and drivers of change. So now this is a commune in the Belgian Ardennes, in the south of Belgium. And as Sebastian will know, Belgium is a great place to do land use change studies. Do you know, and you probably know why, Sebastian, because Belgium has unfortunately been ruled by just about all of the major European powers at some point in history. And what a new invader does when they turn up, the first thing they do is they map out the resources they've got available to them. So if you go back in time, there are brilliant land use maps that have been created by the Austrians, the Spanish, the Dutch, the French, etc., right, who all turned up. So what we could do, and this is what was done by a study I can acknowledge here, was to reconstruct past land use from these data. Now what's interesting about this is that if you ask somebody who knows the Ardennes, especially if you ask a Belgian person, they would say, oh yeah, the Ardennes, I know what that is. It's coniferous forest and grassland and a little bit of cropping. That's the typical Ardennes landscape, right? That is the natural landscape. I've even heard the Ardennes described as one of the last wildernesses in Europe, which is completely balmy, as you could see from these maps, right? That's what people think of the Ardennes as looking like, which it does today. But if you go back to the 18th century, that's a very different picture. There are no coniferous trees whatsoever. You've got mixed land uses. You've got heathland in grey. You've got orchards for fruit, okay? You've got a whole mix. You've got wet meadows. You've got more surface water, etc. And what you can see is through time, you have this sort of complex mosaic of different land uses. Through time, you get the evolution, a change from the deciduous to the coniferous forestry, right up to the present, or the year 2000 in this case, showing what the Ardennes looks like today. So it's a big, big change. What's going on here, and it's actually quite typical, you'd see something similar probably in these alpine-type landscapes, is that one of the biggest drivers here was the introduction of the railways, so improvements in transport. Because if you improve transport, actually you can import food which can be grown somewhere else. So you don't have to be so self-sufficient. So back in the 18th century, these communities would have been really quite isolated. Okay? Because they're isolated, they had to have a diversity of land uses to be self-sustaining in food production. Once you introduce the railways, you don't need that. And you can also use the railways to export timber as well. So there's lots of processes going on here, which are largely driven, again, by technology and innovation, okay, as well as a whole range of other factors. Right, staying in Belgium, I want to switch back to an urban example again. This is another interesting paradox that sometimes people misunderstand about urban land use change. So earlier I was talking about the sort of urbanization through the development of megacities, and that's an important process in many parts of the world. And what you can see as the same process has happened in most parts of Europe as well, but historically. So what this shows, these graphs, they show a population through time, 1830 up to 1990 more or less, and each of these curves represents a commune, so an administrative region in Belgium, just south of Brussels, right? So this is in the French-speaking part of Belgium. And what you can do, if we take one example here, if we go with, let's go with this brown one here, so Chaumont-Gistu. So what you can see is you have a certain population in 1830, it's fairly stable, and then you have depopulation. So these are all rural communes. They're outside of they're just south of Brussels. So you have a depopulation, which is what we're seeing in the rest of the world, which is quite typical, complete depopulation, and then boom, suddenly something happens, right? It's all changed. So now the population is much greater than it was back in 1830. And you can see that pattern repeated, the blue one here. Okay, Villers-la-Ville does the same thing, depopulation and then just starting. And you can see that this rapid upswing happens at different points in time for these different communes. Right? Anyone want to guess what's going on here? Nobody wants to guess. Not even Sebastian. Okay. Let's have a look. I'll explain it to you. So, what you've got here, if you look at the red curve, this is the commune called Rixensart, and you've got another one here, the black one, Otteny-le-Villeneuve. Now, these actually started this upward swing earlier. It started earlier because these communes are closer to Brussels. And what's going on here is a process, it says it in the title, so there's a bit of a clue for any of you who wanted to hazard a guess, is a process known as peri-urbanisation. So what's happening in a lot of European and North American cities is that people are leaving the cities. The cities are actually depopulating. The population of Brussels is actually reducing within its urban core. And people are moving out into rural environments for a whole range of reasons, because they like fresh air, they want the space, they want to bring up kids, but also for technological reasons, because transport is so much better that people can commute from rural areas into a city centre for jobs. So that whole process of where people live has changed completely. And what you'll see is that these communes which pick up later on through that peri-urban process are actually further away from Brussels. So it takes more development in transport networks before people can start commuting from far away. So peri-urbanisation is all about urban development around cities in areas which are characterised by having a rural character, but actually they are partially urbanised, or increasingly so. And that's what it looks at a sort of aggregate level. So the red, this is the green data, the red blodges on this map show the distribution of urban areas, and we can zoom in to a couple of places here. So where we were looking at just now was this area just south of Brussels, there's Brussels, and you get this sort of very scattered pattern of urbanisation. But what's quite interesting about this, you can see there's a couple of zooms there. I've zoomed into Brussels, right? So it's just south of Brussels, so you have urban distribution all over the place. But if you look at the Netherlands, look at the pattern, it's really, really different. Yeah, it looks different. And do you know the difference between the two? Why is the Netherlands different from Belgium, given that, you know, they're very, very close together? Nobody's going to guess. You'll have to start guessing a bit more, sooner or later. Go on, Jonathan. Thank you. Yeah, spot on. Yeah, exactly. Exactly. Absolutely correct. So the Netherlands has amongst the strictest land use planning policy in Europe. So it constrains urban development in rural areas. So you get this very compact development pattern. In Belgium, there was no land use planning policy up until a couple of decades ago at all. So people could build houses wherever they wanted to build houses. And in fact, it's quite interesting. If you go to Belgium in the summer, some parts just south of Brussels here, you think you're passing through forest. If you go there in the winter, when the leaves are falling off the trees, you realise it's a town. Right? So it's completely intermingled. People can build wherever they want to, or could do in the past. So that's the main difference. So another driver, important driver, is policy intervention for land use planning policies in determining land use change. Okay. Right. Right, this is just for Tom, because Tom comes from this little red dot here. Okay, so this is a region of the east of England called East Anglia. Okay, so it's about 200 kilometres across, something like that, I think, Tom, isn't it? So you've got Norwich and Ipswich and Cambridge and Peterborough, the four main towns. So I just want to show you this, because just to take this a little bit further, in talking about some of the drivers and causes of land use change. And it comes back to understanding people and the choices that people make. So you should never forget that land use is a set of human-mediated processes. It's people who make decisions about land use. They have choices and they have preferences. And urban land use is a really nice example of this. Right, so what I'm going to show you here was a study that was done on observational data, socioeconomic data, about the types of households and how they're distributed across this region. Okay? I'm going to toggle between these two slides, actually. So what we're doing is, if you look in this map, these sort of splodges here show individual administrative regions where there are data available for those regions. The four outside maps show zooms into the four major cities that I mentioned earlier. And what we're trying to understand with this is, where do people live? What are the choices that people make about where they choose to live? Because that ultimately affects the pressures on new urban development, right? We want to try and understand those processes. So what we did here was a PCA cluster and a cluster analysis to create this type of table. So what we got are a range of household types here, right? So you've got an isolated student, you've got single people, couples with dependent children, single-parent families, couples with non-dependent children, and retired people, right? So these are, that's a typology of household types which we can interpret from the data. And what we're trying to understand is, where do those people live? Where's the predominant places where they live? And that's what's marked on the map. So if you see here, on the map, you'll see that there are these 12 clusters which are identified. What the figures obviously represent is if you're an isolated student, there's a preponderance for you to live in the cluster 12 on the map, which I'm going to show you in a moment. All right? And some in cluster 10 as well, all right? And less so in 11, but very few in the others. So that's all this is showing. All right? So it's where people want to live. So students, where are students going to live? I'm going to keep asking you questions. They are fantastic. I mean, you're going to go far. Right. There we go. So if we look on cluster 12, so it's the black color, and if you zoom in, here we go. We can zoom into Cambridge. There we are. Nice black blotch in the middle there. They've got quite a good university at Cambridge, nearly as good as the University of Edinburgh. And then if you zoom in here to Norwich, this is the University of East Anglia. Okay, so we've got a nice blotch there as well. So that's good. So things are looking good, actually, for this analysis. So let's pick out a few more. What about single people? Where do single people live? Any of you single people? No one. Oh, gosh. It's changed since my day. City centres, great, fantastic. Let's have a look. Right, so single people, what were they? Hang on. Single people, preponderance in number 8. There we are. Well, that was pointed out. So where do we go? Yeah, this one here. So cluster number 8, we'll have a look at that. And cluster 8 is pink. Very good. Who said that? There we are. Nice blotches of pink in city centre. So actually people are making choices about where they live based on their life stage. All right, and we could go through this. I'm not going to go through all of them. I might just pick out one or two here. So if we look at single-parent families, also tend to be in city centres. Couples, well, we've got 7 and 10. Should we have a look at couples? 7 and 10, so it's blue, dark blue and light blue. Again, you sort of see, well, it's a bit suburban, okay, around the edges of the city, but also quite a bit of blue in the rural areas as well. And actually what you find is as you go through these life cycle stages, that people, when they're students and single-parent families, tend to live in cities, and as they become couples and they have children, then they increasingly move into the peri-urban and rural interior, okay? Then what happens is we retire, right? So let's have a little look. So this is definitely for Tom. So retired people, right? So retired people are here, cluster number 4, right? That's the domination of that type is in here, and also number 6. So we have a look on the map. Come on, who's going to tell me where old people live? The coast. Brilliant. Have you got a house on the coast, Sebastian? No, oh, sorry. Yeah, very good. Do you retire? Anyway, so hang on, what did I say? What was the cluster? 4. Yeah, 4 and a bit of 6. Right. So 4 is yellow, bright yellow. Right. Oh my gosh, look at that. There we are. So people really do live in bungalows on the coast when they retire. I mean, I didn't know it's true, but it's actually true. And actually, if you look as well, you'll also see that they live in the suburbs as well, probably in bungalows in the suburbs as well. So that's what happens. Anyway, so it's quite interesting to do these types of analyses, because again, what we're understanding, one of the big drivers for doing this study was that the demographics of the region is changing. There are more old people, like in other parts of Europe. And if you get more old people and they all want to live in bungalows at the coast, that puts enormous pressure on the coastal area. Right? So we need to try and understand how those demographics will change. And this is what we're basically looking at. We can understand as people go through this sort of caricatured life cycle and then die at the end, then we know where they want to go and what are the pressures on the landscapes in those particular areas. Okay? And actually, well, I'm not going to run the model now because we don't have time, but we also use this type of information to build models of urban land use change based on these choice preferences. Right. Well, that's a bit about the past. So now I'm going to talk a bit about the future. So basically, when we try to understand future land use change, we're trying to use all of the information and knowledge that we learned from observations of the past, right? It doesn't mean the future is going to be the same as the past, as my stockbroker tells me every time I try and buy some shares, but it can be a good guide to the future. So I've been talking about drivers, the underlying causes of land use change, so we need to think about drivers. So these are the types of generic drivers I've been talking about: policy, other socioeconomics, demographics, technology, climate change. Increasingly in the future will be an important driver. So we need to understand the drivers. And the exercise you have this afternoon will be focusing on some of those drivers and understanding them. But we also need some form of model, right? So we want to understand what is the present distribution of land use and how is it going to change into the future. So we have a model, we have the drivers force the model, and we look at how the outcomes change. Because of course we don't have observations for the future, so we have to build models based on our knowledge of how land use systems operate and how individual land users make decisions about land use. So that's the sort of generic way in which we think about understanding future land use change. And this is the type of outcome you can generate. So this shows projections up to the year 2080 for the cropland area in Europe. Actually, it's the EU15, so Western Europe in this case, which is based on 4 scenarios, which I'm sure you're familiar with, the old IPCC SRES scenarios. Are you all familiar with those? Put your hand up if you're not familiar with those. Great, that's good. Okay. Brilliant. So I don't have to spend time explaining that. So you know, these are the 4 marker scenarios, A1, A2, B1, and B2. Change in cropland. Now, what's interesting about this graphic is I don't have to explain all the details, but you just look at the legend, and it's a bit washed out. All of these values are negative. Okay? So this is not an extrapolation of the past. This is based on a model of cropland systems. All those values are negative. So again, we're seeing actually a continuation of the trend we've observed in the past, which is declining agricultural areas. And some of these are substantial. So you look at these sort of bright green areas in the A1, where you remove all subsidies to support farmers, that you get major declines up to 80% of cropland areas in certain parts of the world which have less of a comparative advantage for the production of crops. Okay? Some scenarios, those reductions are a little less. What's going on here? Well, actually, most of this is driven by, again, the assumptions that were made in this analysis about the effects of technology on changing crop yields into the future. And that's actually quite a contentious issue. It's clearly crucial. So if we think about if the past trends over the last 40, 50 years continued in the future, we'd have another 3- or 4-fold increase in production. Again, that's going to equate to a large reduction in the area of cropland required to produce the same quantity of food. The reason it's contentious is that people argue about whether we can sustain that past increase in crop yields into the future. Is there a biological limit to the biomass potential of crops? Right? And it's unknown. So you can only make assumptions. That's why, as we're going to look at later, we're going to explore some scenarios of these types of things. What I do know, when we did this study, we spent some time talking to crop breeders. And what's quite interesting is that when crop breeders create a new variety of a crop, they have to go through a period of trialing, which can take sometimes 10, 12 years. And what they were saying is that past trend is definitely going to continue for the next 10 or 12 years because we have crops that will be able to do that. Right? So we've got quite high certainty for the next period of time. We don't know into the distant future. Anyway, let's have a little look at this. This gives, so it's a bit confusing. The map before gave relative change in cropland. This is the same data for the 4 SRES scenarios, but this time it's cropland area, but given as an absolute percentage. So that means that currently about 23% of the surface area of the EU15 is under cropland. Right? And these are the curves that I showed you up to 2080 on the map. So you were looking at maps for these points here. All right? So that's the sort of spread we've got. And if we think about it, as I was talking about some of these processes, we were looking previously, this is exactly the same curve I showed you earlier of decreasing agricultural areas from the observational data, and actually you could fit a pretty good linear trend through that. Right? Good fit. So what we could do, we can think about it. There's no connection between these data and this model. This is modeled independently, but we can test where our scenarios lie with respect to what's happened in the past, just by simply doing an extrapolation of that red line into the future using that simple equation. And it looks like that. Look at that, isn't that fantastic? So we've got a spread of scenarios which seem to mimic, even though they're totally independent from the observational data, that seem to mimic things that have happened in the past. Okay? That doesn't prove anything. It's just nice to look at it. Right, and this is why it gets a bit tricky. So I'm glad Jonathan is in the room, actually, for the image model. So this is a study that Reinhardt, as you pointed out, is going to reproduce as part of the LUT4C project, which was an intercomparison exercise done in about 2006, 2007, across different land use models. All right? And there are a range of models. So on these graphics, all of the model runs that were done for lots of different scenarios were sort of mapped onto each other by looking at comparisons between the scenarios. So like the global markets, for example, is like an A1 SRES scenario. So you could think of them almost as SRES scenarios. But there was a matching made to compare different studies that ran different scenarios. OK, so what you have here, each of these curves represent one of 7 different land use models that we used in this exercise to generate land use futures. And again, just for consistency, I'm sticking with European cropland areas in this case as well. It's a mix of global models, global integrated assessment models, such as IMAGE and others, for which the European window was cut out. But there are also models that were developed specifically as land use change models for Europe. Okay, so the model I've been showing you is called on here, it's called A-Team. So that's actually curve number 6, if you wanted to know that. And curve number 7, EU Ruralis, that's your boss, Reinhardt, that's his model. So that's there. And we just want to let's have a little look at this data, right? So let's go to the top level here. So again, this shows relative change in cropland projected into the future for an A1 type scenario. So what you can see is, well, actually it's a bit shocking, isn't it, what you can see? Can you see the divergence that you get? Those models are not even agreeing on the direction of change, right? They're going in completely different directions. So even though, I told you all those arguments about why we could probably expect decreases in cropland areas, some models are projected massive increases up to 60% of agricultural or cropland areas in Europe. I don't know where they're going to find the land for that, but, and so, what is it, number 2? IMAGE, it's the IMAGE model, so there we go, so IMAGE is up there. But what you can find actually as well, and you find similar trends around here. Some of them match up a little bit better. That scenario is a bit better. This one is clearly bad. I'm not surprised that this one's bad, because this assumes a free market, laissez-faire economics world, which doesn't exist, right? So we actually have no observational data to test models of that type of world. So it's not surprising that they're really different. But what you can also observe here is that the 2 regional models, curves 6 and 7, actually, even though these were done by 2 independent modeling teams working on different models in different parts of Europe, actually generally at least have the same trends and actually also have very similar magnitudes of change. You can find curves 6 and 7 are quite close all the way through. All right? Again, that doesn't prove anything other than actually global models seem to give a different answer to land use change in the future than regional models. And you can take your pick as to which one you think you would like to rely on. I don't think it actually matters, because a lot of what modeling is about is the discussion and dialogue that comes around from exploring these types of similarities and differences. And sometimes the differences are more illuminating than the similarities. If every model was the same, there'd probably be something seriously wrong. Right, but that's just to highlight to you that we need to be aware of the fact that models do introduce this great diversity in terms of future land use. Right, so going back to the correct model, going back to my model, this is the consequences of all those declines in cropland is that you have abandoned land or surplus land, right, in principle. Whether there's such a thing as abandoned agricultural land is debatable, and I'd happily debate that with you a little bit later on, but we know that there's land which is no longer need for agricultural food production. So what can we do with it? Quick zoom into Aberdeen on the east coast of Scotland, which is this very grey area here, quite fittingly. If anyone's ever been to Aberdeen, it's really grey. And so what we're doing here is actually exploring the use of land for non-food production, right? So actually that frees up land. If you've got land available that's not required for food because you're producing more food on intensive areas, then you can start producing bioenergy crops, right? So different types of bioenergy crops. And again, different patterns of bioenergy. The irony here is that the scenario, the A1 scenario with the largest decrease in cropland areas actually is the scenario that gives you most opportunity for producing bioenergy, and which is quite intriguing because you've got more land that's available. Anyway, so other uses of land that we need to think about. The problem with things like bioenergy in many cases, certainly in the European context, is that it's new, right? It's a novel land use, and we're sometimes faced with this. I mean, it's being produced increasingly, but we don't have a long-term record to really understand what's going on. Now, if this works, it'll be a small miracle. Oh yeah, small miracle. There we go. Right, I'm going to talk you over this. So, talking about bioenergy cropping now. And this is to introduce to you some other notions of important processes that we need to think about when looking at land use change. So what you've got here is a model. It's actually what's called an agent-based model, but I'm not going to go into the details of this, which is looking at modeling the distribution of 2 bioenergy crops. So one is miscanthus, tiger grass, is very high grass used for biomass, and short rotation coppicing. All right? It's partly economically driven, so there's a whole set of assumptions. This is a particular scenario out to 2050. And is that not looping? I'll run it again. So what you've got is the sort of yellowy areas show the percentage area of cropland, okay? So the bright yellows give the highest areas. The red dots that you see is the sort of co-development of energy production plants, because to produce the biomass you need local energy plants where you can generate heat and electricity from the crop itself. And what you've got is this sort of expansion. Now, if you remember from the earlier slides I was showing, I showed you the oilseed rape trajectories through time. Remember that? Well, actually, if you notice some of those maps, if you looked at it, they look very similar to this, other than previously oilseed rape was on the eastern side of the country, but this is on the west. What you're getting here is a process known as spatial diffusion. And what's driving this is simply contact and exchange of knowledge between individual land users. So why would a farmer grow a new crop? They have no experience of growing miscanthus. Why would they grow it? It's a high risk for them. So they have to overcome that hurdle of producing this particular crop. It was the same with oilseed rape. It was incredibly economic to produce oilseed rape. It was actually called black gold, I think, at one stage, because it was so profitable for farmers. Yet, if you saw from those maps I showed you earlier, it took several years before the full potential distribution of oilseed rape was realized. And it's the same in our modeling simulations here. We could even look at what's going on by comparing back to those data. So what I've got here, the red curve shows exactly the same oilseed rape data I showed you previously. The black curve shows the model energy crops that I showed you previously as well. And this is simply rebased, because they're different periods of time, but it's rebased, start from 0 and go from there. And even though, again, these are completely separate data sets, what you find is the model simulations follow this same trajectory. We know it's a spatial diffusion process because spatial diffusion always leads to a logistics curve like this, Sigmoid soil curve, S-shaped curve, where you get people who find that's too high a risk to switch land use, then you get early adopters, and then everyone else piles in and copies them because actually they physically see that their neighbor is growing a new crop, and they talk to them about it down the pub or whatever. Everyone comes in, and then you reach a sort of saturation level where you've used up all of the potential land. Now, the interesting thing about this is, well, first of all, the model seems to be able to mimic observational data, even though it's a different period of time and it's a different crop. But it does seem to be fairly structural that for the uptake of a new novel crop by farmers, it takes up to about 20 years before you get full uptake. Right? So there's a time lag. And that time lag is all to do with this need for knowledge to be dispersed throughout the community of farmers, the community of land users. Now, that's really significant in terms of land use change because, well, in this particular case, the UK government is subsidizing farmers to grow bioenergy crops. And they're assuming, okay, if we give them this big subsidy, then we'll get this amount of bioenergy. Well, as you can see from this, you don't get that. You don't get the amount you expected until 20 years into the future. So it can be really critical from a policy perspective that you have these time lags built into land use change. Right, wine. I had to finish with wine. I know it's a bit early, it's only lunchtime, but this is in anticipation of we get one free glass later, Tom, do we? Is that right? Okay. I just want to introduce another little case example here, because I think it's interesting. So the wine sector is obviously very important in Europe and elsewhere in the world. It's also very interesting from a climate change perspective, because as you probably know, grapes and vines are very, very sensitive to the climate. That's why the climate is such an important determinant of where grapes are grown and the quality of those different grapes. And actually you can observe already changes, because there's long-term records from vineyards, changes in the local climatic conditions in some of these areas, which have, I'm not going to go into all these graphs, lots of things, but it has a direct effect on the phenology of the grape production. So harvest dates are becoming earlier, the grapes are ripening earlier, flowering is earlier, bud break is different as well. Okay, so things are just changing in the wine areas. So this is in Burgundy, these data in Burgundy. You can also see there's been an increase in productivity. So the two main grapes in Burgundy are Pinot Noir for reds and Chardonnays for the whites. So there's been changes, right? They've been quite significant. But where it gets really crucial, and this is what we need to understand. Okay, I say, so what? That doesn't matter. We can still produce grapes here. It's just a little bit different. And of course, we can always adapt to this problem by changing grape variety, can't we? Yeah. So Pinot Noir is a cool climate grape variety. It likes cooler climates. So why don't we just change to Syrah instead, which is a warmer climate. Great, right? Easy. Technological fix solved. No, you can't do that. Of course you can't. If you're a Burgundian, so actually you've probably heard of the concept of terroir. Have you heard of terroir? Well, you should have done. This is terrible if you haven't. Right, okay, some of you heard of it. So terroir is the French concept of the combination of landscape, soils, climate, the culture of the region, which all goes into producing a specific wine, right, from a regulated region, generally. So the terroir of Burgundy is just perfect for producing Pinot Noir wines. And the thing is with Pinot Noir wines, some of the best ones will sell for hundreds, if not thousands, of euros per bottle. Right? It's incredibly expensive wines come from that part of France. So if you're selling your Pinot Noir red for 2,000 euros a bottle, why are you going to start producing Syrah? And how much will you be able to sell your Burgundian Syrah wine for when you've just told everyone that your terroir is Pinot Noir? So there's a big issue here that land users are going to be facing with issues like climate change, that the changing growing conditions, it's not just simply that you can have a technological fix, you change a variety or you change something. There's a whole set of cultural and economic and value-based issues that affect the decisions that land users will make. And it may constrain what they're able to do. So what this graph shows, it's some bizarre, ancient, don't worry about the details, IPCC exaggerated future scenario to 2,500 or something, no, 2,100. And all it does, it just shows the current distribution of the sort of vineyard climatic zones across France. So the white splodges here show the actual distribution of vineyards. So you've got here, which is basically a sort of Mediterranean area. You've got an area here with sort of like Bordeaux and Burgundy, sort of cooler climate. And then you've got the northern part, the Loire, mostly in the top of Burgundy, which is a very cool climate region, right? So that's just climatically driven, climatic thresholds. So for the future scenario, you know, what happens is, well, actually, what was a cool climate Loire type situation becomes a Mediterranean situation. That has got enormous implications for the people in Loire who grow Pinot Noir and Gamay and Sauvignon Blanc and Chenin Blanc, things like that. Those grape varieties are no longer going to be grown in those areas. So what happens? I quite like this bit, though, the arrows going across the channel to Britain. So it's like, whoops, where's it going? And actually, that's already happening. Yeah? There's a lot of production, increasing production of wine in the south of England. And it's actually really good. Take it from me, it really is good. So these things are shifting. And how are the individual land users going to deal with that? Right, I'm going to stop there.